let's have a look here at this one now. So, basically calculate 1 over k. Alright, so 1 over k equals cos theta plus I sine theta to the power of minus 1. So that's equal to cos minus theta plus I sine minus theta. And because cos is even, we can change that to cos theta. And because sine is odd, we can change that to minus I sine theta. Alright, and then now we want to calculate kn plus 1 over kn. That will be kn plus k minus n. So that would be cos theta plus I sine theta power n plus cos theta plus I sine theta power minus n. So that's cos n theta plus I sine n theta plus cos minus n theta plus I sine minus n theta. That's cos n theta plus I sine n theta plus cos n theta minus I sine n theta. Cancel, cancel, and you're left with 2 cos n theta. So that takes care of the second part of the proof. So the last part here is express sine n theta in terms of k and show that cos power 5, I wonder if I can make this a little bit larger, cos power 5 theta is equal to that. Okay, so I can think a couple of ways of doing this, and I wonder if they want us to use the previous formula. So this formula here can help us because we could say n is 5, n is 3, oh well, we have to do the sine part first, and then we can go on to this proof. Okay, so there's actually something in between here. Express sine n theta in terms of k. So you can kind of see what's happening here. So if you were to look at, say for example, kn minus k minus n, that would equal, you know, you're doing the same logic here, but at the cancelling step, instead of the cos's being left behind and the sines cancel, it's the other way around. So you'll end up with 2I sine theta and theta. So you get then the formula sine n theta is equal to kn minus k minus n all over 2I. So that's that part done just by the same logic as the previous part. But I wonder now, the last part here, they want us to show this. I wonder if I'm missing something here about how these all connect up. I get the logic for here to here, and I guess I could replace all of these cos's with these kn's. So this cos 5 theta would be k5 plus 1 over k5, and the same goes here and the same goes here. But yeah, I wonder, I'm going to prove it the way I usually prove it. I'm not sure if it's the best way for this question, but I just can't quite see what way they're leading me. So I'll just do it the way I usually do it here. Okay, so you've got, well, I'll just remove this to make more space. Basically want cos power 5 theta. So you have cos theta plus I sine theta power 5. That's equal to cos 5 theta plus I sine 5 theta. And then if I just put Pascal's triangle here, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and then the next one that we need would be 1, 5, 10, 10, 5, 1. And we're just looking for the cos here. So, oh, actually, that's the other way around, isn't it? Yeah, I see now. I can't do it the usual way because it's yeah, usually it's the other way, isn't it? They want cos 5 theta, not cos power 5 theta. Alright, so yeah, I guess I do have to use this one here when n is 1. So what I'm going to say, cos theta, or 2 cos theta, is k plus 1 over k. That was it, wasn't it? Better go back and make sure. Yeah, 2 cos theta is k plus 1 over k. Actually, I'll just leave that up there because then I can see if I'm getting to it. So cos theta, 2 cos theta is k plus 1 over k. So if I power 5 both sides, I have this. Okay. Now, let's expand. So that's 2 power 5 cos power 5 theta. That's equal to k power 5 plus, where's my triangle gone? 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Okay, so the next one here is 5, and then that's a k4 over k, and then the next one's a 10, that's a k cubed over k squared, and then another 10, k squared over k cubed, plus a 5, k over k4, plus 1 over k5. Okay, 2, 4, 8, 16, 32. 32 cos 5 theta equals k power 5. And we'll pair it off with the last one, 1 over k power 5. And then the second one there is 5k cubed plus 5 over k cubed. And then the middle one is 10k plus 10 over k. So this is equal to k5 plus 1 over k5 plus 5 k cubed plus 1 over k cubed plus 10 k plus 1 over k. Well, we can see here it's exactly this formula again when n is 5. So that one there is going to be 2 cos 5 theta, and then this will be 10 cos 3 theta, and that one's 20 cos theta, and that's 32 cos power 5 theta. So if we divide by 32, and then that's 1 over 16, which we can take out. That's 5 over 16. We can take the 16 out. And then that's 10 over 16. We can take the 10 out. Perfect. We've matched that up exactly. I don't know if that's exactly what they wanted us to do. I'm I'm a little bit confused by this reference to the sine. Like, I get this, I had to use that. And I get this because that helps us do that part. And I get the last part. But I'm just a little confused about why they bothered to have us do the sine theta and theta, since it didn't really link into the rest of the question, at least the way I did it. So perhaps I'm missing something here.